Hi and welcome. My name's Jeff Kilford and I look after the client portfolio for Intel in the UK. But prior to that, I spent 26 years in Intel's IT department, doing pretty much every function you can imagine. And a good chunk of that, about a decade, I spent looking after the client fleet at Intel. So that's 140,000 devices owned by 100,000 lovely but very demanding IT customers, our employees within Intel. And they were all over the globe, highly mobile. About 80% of the devices are mobile. And very rarely did we have the luxury of having a local IT department to support them. And we've always been very passionate about clients, of course, as well as the other products that Intel make. But at the moment, we're very aware that the PC has become an extremely critical complement to our existing pandemic lives. So it enables us to stay connected to our friends and family. It allows us to stay connected to our businesses. And now more than ever, the IT department is experiencing a huge amount of pressure. Back when I looked after the client fleet, the release, the cadence of operating systems was about every 3 years. Major software releases could be constrained to about 6 months. What we've noticed over the last 5 or 6 years is the dramatic acceleration of the need to protect individuals on a more regular cadence, and software generally now, in terms of the sheer volume we have to put out into the enterprise to support all the personas that we support, but also relative to the ability to protect ourselves, the individuals in the company, their identity, their privacy, and the intellectual property of the company. It just puts a huge demand on what was traditionally a very demanding role anyway. So let's talk a little bit about competing pressures, because this is a problem associated with the modern workforce, even outside of the pandemic situation we find ourselves in at the moment. What we've witnessed over the last 10 years are some macro pressures being exerted on the IT department. This is things like the necessity to digitally replatform the businesses, the companies that we serve. And if we didn't do that, then those businesses would soon become irrelevant. There's a lot more legislation being exerted upon us as well. GDPR is an example, but we're probably never going to get to the situation where we can say, oh great, this year we have less legislation to deal with relative to last year. Threat as well, in terms of the landscape and the sophistication of it, has dramatically transformed. I don't think we'll ever get to say, oh great, less people are trying to attack my business this year relative to last year. It's migrated from a point where somebody had to be a talented individual. They needed to be able to write software, and then they needed to understand how a PC worked or a server worked if they're going to attack a server, and then they could launch their attack. These days, malware can be created by anybody that's got a torrent client. They can download a kit, they can press a few buttons, and then, hey presto, there's a new malware variant. We estimate that there's around 500 million live malware infections currently in the world. And we also estimate there's about 500,000 new ones every single day. So it's hard to get an accurate read, but malware is still a huge part of our lives. The problem is the threat landscape has migrated to a far more sophisticated form. In 2017, when I started talking about the advent of BIOS malware, it sounded quite exotic. And then in 2018, LoJax became a thing. It was a widespread, successful and insidious attack at the BIOS level. And if you didn't have BIOS protection in there, similar to the stuff that we do with vPro, then there's no way that that system could understand that it's been infected. There's nothing that we can put in the operating system and above that can look down into the BIOS and see that it's been compromised. So that became normal. Live threat to memory, that's normal. Even worse, because the cybercrime industry is worth about $6 trillion, we now see that organizations, criminal organizations, are motivated to try and tap into that lucrative market. And so they may have access to certainly programming capabilities and skills that individuals on their own wouldn't have, but perhaps manufacturing capabilities as well, and the ability to intercept and duplicate components on a device. So a huge amount of these macro pressures exerted on the modern IT organization. And then internally as well, we see competing forces associated with investment into IT and explosive demand for services. I've spoken to about 400 IT organizations over the last 10 years, and I hear quite often that they're considered the cost center. The budget is sometimes held outside of the IT department itself, and there's a real demand there to optimize and make that organization efficient. But at the same time, they are experiencing that explosive demand for growth. And it's not just bandwidth and storage. Increasingly, it's things like experiences. The device itself, the PC, has become a HR conversation. It's relevant when we try and attract and retain the best talent coming from universities. And this year we saw the tipping point of millennials, in that they are now the greatest constituent of the workforce in the UK. Their expectations are different to my expectations when I had a PC. They expect it to be really nice. They expect it to look sleek. They can be proud of it. They want to seamlessly blend their personal and business experiences on powerful devices that compute all day long, particularly if they're on a laptop device. So all of this is relatively new, some of it external and some of it internal. And then there's one huge macro problem that we have that's teeing up the conversation that I want to talk about today. And that is that if we aggregate the demand for all of the compute we need to solve the big problems that humanity needs to really get a grip on, and then we put together all of the CPUs and GPUs on the planet, and we look at the gap between the demand and the supply of the compute power as an aggregate number, then we are way off. And even more troubling, over the last few years, the gap has been widening broadly. Now, we think part of the problem is that we've got into the situation where the cloud is considered the place where you would run complex workloads. And this is where machine learning AI conversation creeps in. And that the client sometimes is used just for visualization of what's going on in the cloud. Now, we have demand signals from new job codes, data scientists, content creators, and a whole slew of new job codes that we haven't even imagined 10 years ago, that demand to stay in the moment with their data. They want powerful computation at the edge and the best of both. They want cloud, they want edge, but they want more power there. And increasingly workloads are beginning to shift towards a more machine learning-like and AI aspect to them. And that's perfectly natural, and it creates a huge opportunity. Let me talk a little bit about the stats, and then we can talk about the advent of what's happening with AI at the edge. So some of the stats that drive our conversation around AI at the edge, they're based on what universities are scheduling in terms of their programming content, their syllabus. Then we're seeing what happens with the existing community of software developers out in the wild. And we've got good data that suggests almost a third of them in the last 12 months have been working on machine learning workloads at the edge. We also predict that if we can build far more capable machine learning devices at the edge, we can migrate what is most appropriate to have at the lab and the desk in terms of workloads, about 20% of workloads out of the data center. That's great for two reasons. We've added computation at the edge that helps us, it narrows the deficit between the demand and supply issue that we have globally. We've also freed up capacity in the data center so that can be, that can be filled with those more complex workloads. So as an aggregate, we're beginning to make a dent into that gap. And of course, the way that natural interfacing works, the way that speech recognition works, noise filtering, video clarity, blurring, and so on, there is a very heavy machine learning bias. And if we can accelerate all of those workloads very comprehensively with machine learning quite easily, and that's the new normal situation we find ourselves in terms of the workloads we run every day, and this is a positive thing. Now, let me give you one example that Intel does. We've been doing it on our 10th generation products, and we'll be doing it increasingly in the future. There's a suite of solutions in vPro called threat detection technology. Within there is accelerated memory scanning. Now, this is really neat, and it gives us a hint at where we're going with the machine learning capability at the edge. It's not just encryption of memory, or it's not just looking for pattern recognition via the CPU. It's a very chatty workload when you're looking constantly at memory to see if there's an intrusion. What we've done is we've offloaded that to GPU. Not only that, we've applied machine learning heuristics to it. So over time, it gets a lot smarter in terms of what's normal behavior for memory, and it can legislate for what is abnormal. Now, if you've got Windows Defender and you switch on this memory feature, it will look to see if vPro is there and accelerated memory scanning is available. And if so, it will run that workload on GPU. So here we have a pretty simple implementation where we're doing a couple of things that give a big hint at where we're going with our platforms. We're offloading a traditional CPU workload to GPU, and we're applying smartness to it. We're applying the AI capability to it as well. So it's a better way, relative, if you think about how security products typically work, they typically legislate for what is known in terms of the malware community. And then you push pattern files around the enterprise to mitigate that issue. If the software could be rewritten in a way where it just becomes far smarter in terms of what's normal and legislate for abnormal, then the need to know every single malware variant out there kind of goes away. So it gives us a big hint of where we can go with these capabilities. And it applies it at lots of levels. What we're doing within Intel, and I've got another use case coming up later, is even before the operating system starts, we can apply machine learning to have a much better layer of protection, and also a better way of managing the power cycles, the battery, the power drawn from the wall if it's a desktop. in a way that improves the overall experience of the device. It allows us to jump forwards in terms of the capabilities of these platforms, especially on the laptop. Latency is a huge factor when it comes to machine learning, and this is one of the reasons why communities that use a lot of data don't particularly want all of their workloads to run in the cloud or to have to visualize it only through their device. The implications for security are huge, so I've talked about that already. And in terms of cost, I mean, one of the things that we did in Intel IT, one of the opportunities I had was to build a solution that it was a very simple telemetry solution. It just harvested simple data from the devices. And then we had an agent on the devices that could run some self-healing solutions. Very simple things, but it had to be smart. It had to figure out when there were false positives in Event Viewer cropping up, so it can read those events. It had to figure out when there were conditions on the client that when they became breached would impact the overall ability to be patched and things like that. It was very simple, very straightforward. We did it with a really small team. But that capability last year solved over 200,000 rudimentary incidents. It frees up the service desk from doing a lot of mundane work, and it keeps the employees up. So if we roll forwards to what we can really do with AI at the edge, this is a very old foil. I've kept it in here because even 18 months ago, AI was becoming ubiquitous at the edge anyway. The option to run it was pretty much bounded to CPU. Now that was the real issue. That's the issue that we really want to tackle with our modern platforms. But there's probably something in these use cases that seem familiar whether you're in a consumer setting or a commercial setting. And we could update the foil today, and there would be an awful lot more use cases on there, and it would be out of date next week. Because what we found is as we build accelerating engines for neural networks on the client, and we offload machine learning workloads onto GPU from CPU, these use cases dramatically accelerate because the industry, the ecosystem, they're very hungry for new and interesting ways to rewrite their software. And if you think about where this is going, we're at this huge inflection point that we've not seen for decades in the IT industry, where so much is being rewritten to leverage machine learning acceleration and AI workloads at the edge. Imagine the IT build we're going to be running in 2022 and 2023. And imagine the decision-making process. Say you take an 11th gen mobile platform from Intel, we get a commercial SKU that comes in a toughbook form in Q1. Say you opt out of buying a platform with these accelerators that can dramatically speed up everything that we run on that platform because it's not just a CPU conversation anymore. Will we be able to run the IT build of 2023 effectively if we can run it at all? You know, probably not. Probably there's going to be some impediment to that overall experience, which feeds into one of the competing pressures we're trying to manage in the first place. And this is a more modern version of the foil. There's some things on here that probably look very familiar to you. Certainly with video conferencing, you know, as an advocate for our products coming out of Intel, I get early access to some of the capabilities that are available. And at the moment, I'm able to leverage some of the capabilities that improve my video conferencing capability. I'm on a very skinny link. You know, the big fiber folks don't want to come down this street and hook me up with some amazing bandwidth. And there's a lot of contention for the router as well, as my kids are very active in terms of their gaming. We all have smart devices. We're always connected. So ensuring that I don't get impacted by my skinny link or router contention, and I can see what everybody is talking about and displaying through my video conferencing capability. I can very easily blur the background if I need to, you know, very speedily, or apply some fun backgrounds, interesting backgrounds, or on-brand backgrounds. That's all important. And that software understands that my particular device can accelerate all of that. So it's seamless, it's very easy. But this is the tip of the spear. You know, if we think about all of the workloads that can benefit from acceleration or a shift from traditional compute into something that's far smarter, then I think we get a real inkling of where everything is going, how massive a transition it is that we're going through at the moment. Here's an under the operating system use case that I've alluded to earlier. This is something that's been available since our 10th generation products. Going forward, it's something we'll continue to invest in. A traditional CPU tends to burst very hard. You know, it goes to its maximum frequency when we perform work on it. Then it exhausts its thermal budget and it backs off so that the fan can come off. It can cool the skin temperature of the devices if it's a laptop, and then it bursts again. This is the traditional way that CPUs work. The CPU that I have doesn't do that. It figures out over time what I need and when under certain conditions. The only thing that I really notice is that my battery life is excellent on my laptop, and that it very rarely has the fan come on, and also the skin temperature always stays cool. So I get a much better experience overall, and there's probably some elements of preservation of devices because I'm not making the hot, cold, hot, cold, hot, cold. But the point is, we can do this under the operating system. We can do it in operating system. I talked a little bit about Defender. We can certainly do it with the software ecosystem as we re-architect our stuff to leverage this. Some of these workloads were absolutely impossible in previous incarnations of our products. You needed some really powerful compute or a completely different way of orchestrating your workload if you really wanted machine learning to come out of the data center onto the client. And that's why with Tiger Lake in particular, that we've released in a consumer variant, we've released about a month or two ago. We'll get a commercial variant coming out in Q1 and a Toughbook variant will be available. We've completely redefined the orchestration of all of the compute on that platform. So it's not just a CPU intensive situation. That is critical. The CPU is still probably the most critical component on the overall platform. But the platform itself is where we're beginning to move the conversation around the experiences for our employees and also for the IT organization. If we imagine that the IT organization will now be able to put more protection onto the device because some of the workloads are going to run on GPU. Because we've offloaded our neural network accelerator to discrete silicon as an accelerator on the platform. So the CPU nor GPU have to worry about that at all. You begin to get a real sense of how much power we've managed to put onto the platform. Even though the CPU on Tiger Lake is about 20% better in terms of overall performance than its previous generation, so it's a huge leap. It's these accelerators that dramatically change the game. You know, we think we're very unique in terms of this architecture. In fact, we are at the moment. And we think it's just in time, A, for the pandemic situation that we're in at the moment, but it's that 2022 workload, 2023 workload. If we don't have this acceleration, if we don't have this federation and orchestration of these far more powerful features, then we've got to think about what we're going to miss. We've got to think about what we can't do in the future. Now, I talked about the video conferencing set of workloads. This is how we add up, those accelerators here, as you see them, into one particular use case that's around video conferencing. This is where all of those features play. I hope you haven't been able to hear my dog barking. You can't hear the washing machine that's going in the utility room next to me. You haven't been hearing my Wise Fitness class in the front room. I can hear them all, and I hope the microphone's not picking that up. I am hoping my G&A solution is fixing that for me. So this is a real test because I'm only doing one take today, and I'm hoping that none of these noises are coming through. It's also not proprietary to Intel. So Deep Learning Boost is a unique instruction set. We put it on CPU. It helps with the acceleration of CPU workloads. But we support the Windows machine learning ecosystem, Google's as well. It's not something that we're building in isolation and we expect to have to create an ecosystem for it. This stuff just works, and it works across a broad range of products. So the reason why I mentioned Tiger Lake in particular is because as the ecosystem, software-wise and platform-wise, dramatically transform to leverage machine learning and AI, you need a generationally massive leap in the architecture that we put together on the platform. So we think this is perfect timing. And this is just one foil with all of the interesting pieces on it that drive that acceleration and enable us to start migrating workloads traditionally out of the data center. Now, the consumer variant is amazing because the XE graphics capability is remarkably powerful as an integrated graphics engine. It offsets about 80 to 90% of discrete graphics purchases for laptop. It is that good. And it also, from a gaming perspective, as I am, it allows me certainly to play esports very smoothly on a 15-watt device that's highly mobile, but it also allows me on the slightly more powerful 25-watt device to pull down use cases that were typically on our H series, which is our kind of mobile workstation series, and that's AAA titles, not at ultra graphics or anything like that, but a fundamental kind of good enough, well over 30 FPS, looks nice, looks really nice, and plays very well. So we've really invented a category. It's what we call traditional use series, it's thin and light series, that's pulled down a use case from H. And we expect this to translate into the commercial environment as well. If you think about all those virtualization products, certainly the Adobe suites, the CAD packages, CAM packages, we've now got a very thin and light device that's pulling down mobile workstation use cases and will be available for commercial client early next year. So it is transformational. This is not an incremental release. It also plays into what we call Project Athena. With Tiger Lake, we've rebranded this to Evo. So it has its own brand specific for 11th gen. And as you can see from the graphic, we've put the artificial intelligence component in here. One of the reasons we wanted to redefine the Ultrabook specification into Project Athena is there were things like 5G that we think are absolutely critical for always connected devices that again are revolutionary. They're not really incremental to 4G, but it's this AI component underneath the operating system, in the software stack that allows us to do these really transformational leaps in the computation of the device and what we can visualize on the device, the usage overall, with the 15-watt envelope, the 25-watt envelope. So I hope that was interesting for you. Please enjoy the rest of the event. And I'm Jeff Kilford, and thank you very much for listening.